So good morning. So very important question from the chapter of semiconductors. So one important point before you start watching this video is that the format of the video which I do are discussion and explanation. I don't do 30-second solutions. So if you're one of those students who need a solution in 1 minute 30 seconds, don't watch my videos. I go deep inside a topic, even if it is a simple topic or a difficult or a complex topic. I go deep inside the topic, and my whole emphasis is concept learning. Okay. Now, this question pertains to the conductivity of semiconductors, and the question is a bit difficult to understand because of the language being used in the question. So, if you read the question very carefully, the conductivity of semiconductor increases with increase in temperature. Okay, so the conductivity, it does increase, that is a fact, right? But why does it increase? Because of the reasons given below. We have to identify the reason. So if you look into the first reason, okay, the number of free current carriers increases. So if you notice a semiconductor, you have a valence band, and then you have a barrier, and then you have a conduction band, right? So this is 1.1 electron volt of forbidden gap. This is your valence band. The electrons here, because of increase in temperature, jump and reach the conduction band, right? So if they are in conduction band, they definitely contribute towards increased conductivity. The more electrons you get here, the better it is. And they leave behind a hole also here, right? So a hole is left here and electron. So the increase in temperature results in generation of electron hole pair also. Holes also contribute to the flow of current, and the electrons also contribute towards flow of current. Now, when you increase the temperature, you can notice that the free carrier charge density increases, right? Okay, so now let's start discussing the second part of the question, which is tricky. Now we are going to discuss, now we have lot of charge carriers because of increase in temperature, lot of stuff in the conduction band, but now lies the trick. This charge carriers, for example, electrons in the conduction band, are now going to face friction. So let's discuss what friction am I referring to in the second part of this discussion. But one more thing happens is the thermal agitation of the lattice, the agitation will grow, right? Due to temperature also impacts the atoms, right? So silicon atoms will start vibrating. Okay, so they start vibrating. Once they start vibrating, what happens is the drift velocity, right? So the drift velocity gets impacted. Now, what does it mean? It means that the charge carriers which get generated, okay, the charge carriers which get generated, which are electron and hole, they meet with collision, okay, collision with the atoms. Okay, so the silicon atom starts vibrating, and the charge carriers like electrons and holes meet and undergo collisions with the atoms in the lattice, right? And that reduces the drift velocity. So the drift velocity goes down, which means that the mobility of the charge carriers, okay, the mobility, which you might have seen is written as this mu E and mu H, it goes down, right? If the mobility goes down, the conductivity will get impacted. If you see the formula of conductivity of a semiconductor, it is proportional to charge density. It is also proportional to the mobility. But as you can notice, the charge density is increasing because of increase in temperature, but the mobility goes down because of the collisions. So the electron which is moving under the influence of, for example, an electric field or temperature, that electron will now collide with the vibrating atoms, and therefore its drift velocity will go down. If the drift velocity goes down, the mobility goes down, because mobility is given by, sorry, the mobility is given by the drift velocity divided by the electric field. So if your drift velocity goes down, electric field will not get impacted because of increase in temperature. Now in semiconductor, the good part is the increase in the charge carriers outweighs the loss of mobility due to the collisions. So collisions are reducing the conductivity, whereas the charge carrier density is increasing the conductivity. But who wins? The charge density wins. So if you read this question very carefully, what you will notice is the word mobility has not been used. The word which has been used is the relaxation time. Now, relaxation time is a term which is generally seen in conductors. Okay, so this is a bit of confusion. This could have been called as the average mean life kind of thing before the electron and hole recombine. Okay, so the relaxation time decreases is same as saying that the velocity, right, the electron is moving under, because of the temperature, but because of the atoms, the electron is colliding, and therefore the time it had to relax reduces. The collisions of the electron with the atomic structure of the silicon, for example, increases, and therefore electrons are not able to relax, right? So the reference to relaxation time is an indirect reference. Actually, I have given the answer in the form of the number density of charge carriers, which is very clear, and the relaxation time I've answered in form of the drift velocity, because drift velocity decreases is as good as saying that the relaxation time decreases. So I hope the concept is clear to you. The terminology being used by NCERT model question is a bit different. If I were to give this question, I would have given this question in terms of number density of charge carrier and the mobility of the charge carriers. The mobility goes down, but it loses the battle. Mobility tries to bring down the conductivity of the semiconductor, but the number density keeps on increasing with increase in temperature, and it wins. So the overall impact is that the the conductivity finally it goes up because of increase in temperature. So I hope it is clear in your mind. I was more in a discussion mode than in answering your questions straightforward. So listen to this video again and again, and you will be able to understand this. However, one more small discussion on what happens to conductivity of metals when the temperature rises. So listen to this also very carefully. You can get a question on this also. And in the case of metals, relaxation time actually appears as a terminology. It is rare to find the word relaxation time in semiconductors, but NCERT has given it. To me, relaxation time was more about drift velocity reducing and electrons not being able to travel a lot of distance. Before they start traveling a lot of distance, a collision happens. But in the case of metals, the situation is different. Listen to this discussion. What happens to the conductivity of metals when the temperature rises? Let me tell you what happens in metals. In the case of metals, if you have the scenario of the uh, the charge density is increasing because the number of electrons is increasing, there the mobility of the electron is impacted so badly that the conductivity of the metal decreases finally because of increase in temperature, because mobility becomes so low that even if you have high temperature, it does not matter. The conductivity of metal therefore decreases. But in the case of semiconductor, the mobility is not able to win the battle against the number density of the free electron, which keep on increasing. So thank you very much for your time today. I hope you like this discussion. I have a huge list of questions and answers given on semiconductors in the playlist. Go and watch them, and you should be able to learn a lot about semiconductors. Thank you very much, and wait for my next video.